Hi folks, this video should help you if you're having any questions about the exploration sheet that's on radians. We completed the first half of this sheet in class, so I'm mostly focusing on the back side of the sheet where we start with the definition of a radian. So let's move on to the first slide. I believe we had established on the front page we were working with the fact that when the writer of the carousel, I think his name was Austin, rode for one radius, we saw in two different instances when our circle was 5 meters and 9 meters that meant he went through a 57.3 degree angle. All right, so we've established that fact that one radius is the same thing as about 57.3 degrees, and that is a rotation of one radius is rotating through about 57.3 degrees. And so that idea, and this was regardless of how big the radius was, that gives us the idea that we can actually measure angles using something other than degrees. We can talk about measuring angles by how many radii they span out, okay? So 1 radian is the measure of an angle formed by an arc whose length is equal to 1 radius of the circle. That's what we're going to call a radian. And so the rest of the problems here on this back side of the sheet is to get you familiar with trying to measure angles in radians as opposed to degrees. So just to get started here, so if 1 radian, we can change that word to radian, is about 57.3 degrees, then how many degrees are there in an angle of 2 radians? See if you can pause the video, see if you can figure that out, and then we'll check that answer. All right, check and see if this is what you got. So naturally, if 1 radian is 57.3 degrees, then 2 radians would be twice that. And so we just got to multiply and we get 114.6 degrees. Okay, let's take a look at some of the other problems on this side of the sheet. One way to make this process a little easier is to, if you remember, the length of the radius doesn't matter, so this process will become much easier if we just have the radius length be only 1 meter, which of course ties into what we were doing with unit circles. So we're just going to make the carousel be riding along a unit circle with a radius length of 1 meter. So to get started, let's see, how many meters does Austin ride if he rotates through just 1 radian? And then we want to figure out through 2 radians. All right, keeping in mind that our circle has a radius of only 1 meter. Why don't you pause the video and see if you can figure out the answer to that. Perhaps you were thinking that you would need to use your circumference formula here, but you really don't. If you think about it, since the length of 1 radius is only 1 meter, and we're going to rotate through 1 radian, of course that means 1 radius, then that means that Austin's going to ride just 1 meter for 1 radian. And this is why this makes it a little simpler. Every radian that he travels is going to equal 1 meter going around the circle. So of course 2 radians would just be 2 meters. So this makes it easy to figure out how many radians we might be traveling. So let's turn the question around now. If he makes 1 full rotation of the carousel, all right, goes all the way around the circle, how many radians has he traveled through? All right, in this case you may be giving your answer in terms of pi. All right, so pause the video, see if you can figure that out, keeping in mind what we just said over here about the number of radians equaling the number of meters. All right, see if this is what you got. So when our radius is 1 unit, And then the number of radians equals the number of meters it goes around. To do a full rotation, we just got to figure out what the circumference is. And when the radius is 1 meter, our circumference is simply 2 pi meters. So that means he actually goes around 2 pi radians. So an angle of, say, 360 degrees is the same thing as 2 pi radians. Here, we'll write that. Now, mind you, the number 360 is not the same as the number 2 pi, right? 2 pi, we were talking about this in class, is about 6.28, but 360 degrees is equivalent to 2 pi radians when you're measuring angles in standard position. Usually when we're working with radians, we keep the numbers in terms of pi. So we would most likely say 2 pi radians. We wouldn't say 6.28 radians. All right, let's take a look at some of the other things. So keeping in mind that 360 degrees is 2 pi radians, how many degrees would there be in a rotation of pi radians? Why don't you pause the video and see if you can get that answer. So hopefully you were thinking that to go from 2 pi to pi radians, we just need half of 2 pi, just to kind of show that out. So half times 2 pi would give us 2 pi over 2, which is the same thing as pi. So we just need half of 360, right? So pi radians is the same thing as 180 degrees. All right, so let's keep going. How many radians are there in a rotation of 90 degrees? So now we're going back even further. You still want to give your answer in terms of pi. Pause the video and see if you can get it. Is this what you got? All right, so hopefully you were thinking, well, 90 degrees is half of 180 degrees, so we just need to do half of pi, or half times pi, and that would give you pi on top and 2 on the bottom. So we usually say that a 90-degree angle is the same as pi over 2 radians. Here, let me write that. Okay, so hopefully this has you well on your way to finishing. I think there's 2 more parts to this sheet. See what answers you can come up with. Don't leave it blank. All right, hopefully you'll be correct. But just so you know, this is kind of the way we present radians. Pi, we leave pi in the answer, and we also a lot of times use fractions. So so we get like pi over 2, you might see pi over 3, pi over 4, pi over 6, those kind of numbers. All right, so we'll see you back in class, and we can check the rest of it. Hope this helped.